Hello friends and viewers, welcome back to my channel Learn Easy Maths. Friends, as I told in my previous videos that very shortly I am going to start a series related to the 10th standard. Now in this week that series is going on, and among this series today the new topic is, can you see this one? Thales theorem. Thales theorem is our today's topic. Here I am going to tell you what exactly the Thales theorem says. Who is Thales? Thales was a great mathematician believed to live many years ago. Just he was in BC, and it is also well common notion, and the people believe that he was a very great teacher and tutor of the great mathematician, another person, Pythagoras. Okay, this much is introduction about the Thales. What is a theorem now? We will just discuss little bit about what theorem. Theorem is a geometrical statement to which we will prove it in a logical way. Any geometrical statement, just we have in Euclidean introductory part of our geometry, axioms and postulates are there, where we do not have much more substantial what we can say the quantum for the proof. But here in proving these geometrical theorems, we will first deduce the logical deduction. We will introduce some logical reasoning. On the basis of that logical deduction and that logical reasoning, we will prove it. Okay. This is a theorem which I have taken from very popularly known as Thales theorem from 10th standard. Remember. Actually, what is the theorem and how it will be proved? First, the theorem will have a statement. It states that what the theorem is about. Next, its figure. It will show you the figure. This is the statement which the figure indicates. Okay, which the figure interprets the statement and the vice versa. The third thing is its data. The basic information about the theorem is called its data. Remember, the basic information. The next is first statement, what it is going to say and state about it. Next, its figure. Third, its data. And the fourth is its requirement of the theorem, what is to prove, what the statement says and what we require and need to prove. Understand? Now, the next thing is that after having all these process, we will proceed it to prove by proof. How the proof is, just how the proof is being proved, or the proof is being just mentioned. We will prove it with the help of the logical deductions and logical reasoning using the figure, the data and its other part. One additional and arbitrary in mathematics, no, we use one word arbitrary. What is that arbitrary? Additionally, construction. In the figure, we will construct from additionally, so that still we can have a logical proof. This is all about the introductory part about the theorem. Let's say that. Viewers, can you see the figure? This is a triangle. Generally we say that what is a triangle? A figure formed by three non-collinear points joining to their vertex. A Triangle has 3 sides, 3 points and 3 angles. Okay. It is the least polygon. The first polygon is a triangle. Right. This Thales says that in any triangle, you take any triangle of any of the type based on the sides, scalene triangle, isosceles triangle and equilateral triangle. Based on the angles, acute angled, right angled and obtuse angle triangle. In any triangle, see that ABC is a triangle. A line drawn parallel to one side of its triangle. How many sides do we have? We have 3 sides. And what the Thales theorem says that draw a line parallel to one of the sides of the triangle. Okay. So BC is a side of the triangle which I have drawn a line D parallel to BC. Okay. If I drawn the line parallel to the BC, what does this line D do? This line D intersect the other 2 sides of the triangle. Generally we have the 3 sides of a triangle, but I have drawn DE parallel to BC. Then this DE intersect AB and AC at the two distinct point at D and E. This is only the main part of the theorem. A line drawn parallel. Condition that the Thales theorem is only holds true and holds good for the line parallel, not any other type of the line. Either it is an oblique or it is a just curved line or it is a zigzag line. Nothing. A line drawn parallel to one side of the triangle BC. I have drawn DE parallel to the BC. This line intersect or meets these 2 sides at the point D and E. Then what does it do? This line which intersect the point D at D and E, they are divided in equal ratios. They are divided proportionally. What is that? The 2 equal ratios are said to be in a proportion. If we cross multiply their antecedent to consequent and vice versa, or the product of their extremes is equal to the product of the means. Little bit I would like to just recall and recollect this part. A by B is equal to C by D. Isn't these 2 are equal ratios? And when you cross multiply AD is equal to BC, then we say that A is to B so as C is to D are in a proportion. They are equal ratios are said to be in proportion, right? This is what it say, a line drawn parallel to the BC one side of the triangle, the other 2 sides are divided proportionally, divided in equal ratio, isn't it? What does it mean now? Say the triangle is this ABC is a triangle. Generally, I will give its interpretation, geometrical and also the arithmetic interpretation. Say this DE is parallel to BC. Understand? Okay. Assume that AB has some measure and AC has some measure. That measure is divided into equal ratio by the point D and E. D on AB, E on AC. For example, AD is 3 centimeter and BD is 6 centimeter. And this part will be what it is. It is an 18 centimeter. Say I don't want to take a big number. I would like to take like it is 12 centimeter and 24 centimeter. This is the way that D divides AB and AC in equal proportion. You may be surprising enough that what is that equal proportion. See that what I have just taken this statement. ABC is a triangle, alright. D is lying parallel to the BC, okay. Then what is the consequence and the result? Then these 2 points divides the AB and AC into equal ratios. Then take an example, AD by DB is equal to AE by EC. I would like to pay you attention fully. So what is AD? 3. What is DB? 6 is equal to what is AE? 12 and what is EC? It is 24. They are in equal what they are in equal ratios, then we say that these two are in proportion. What is the test for the proportion? Make a cross multiplication, isn't it? Then you multiply 3 into 24, then you multiply 6 into 12. See the product, 24 3s are 72, 6 12s are 72. Then we can say that 3 by 6 is equal to 12 by 24. They are equal ratios. Then these two ratios are in a proportion. Do you understand? This is applicable and true, hold true for, and just it is hold goods for all the statements, all the theorem which are in a proportion. Instead of that 3, you can take another example. Let it is a 4 and it is an 8. Then, for example, this is 32. This EC is 32. What would be the AE? Then see that 4 divided by 8. It is 1 by 2, isn't it? So what is the actually, we have a proportion here. This is, now you have to multiply with, this is a 16. The 4 divided by, look here, 4 by 8 is same as 16 by 32. Then it is 4 1s are, 4 2s are, 16 1s are, 16 2s are. Then they are equal ratios and they are in a proportion. What is the proportional factor? I would say that for 4 by 8, what is the proportional factor? The proportional factor will be 4 4s are 16, 4 8s are 32. This is the way what the Thales theorem says that. I hope you followed it, isn't it? Now proceed on to its proof in simple way. I am not going to take much more, and also in a very complex way. I would like to take you in a simple and understandable way. I hope and I will be able to take you in a simple manner to learn it. Okay. As I told you that while we prove a theorem, we need to have some arbitrary work. We need to have introduce some additional things. For that one, I am going to just make some construction. Join BE and join DC. Alright. The next thing is draw EN perpendicular on AD produce, that is AB. EN. Alright. Then draw DM perpendicular on AE produce AC. Right. This is DM and this is EN. Any perpendicular drawn to a base or on the side, then definitely it forms the right angle, isn't it? These two are right angle, these two are right angle. So we are not worried and we are not concerned about what is the right angle, but only we are having some different aspects to prove the Thales theorem. See the children, see that one. First, what is given? DE parallel to BC, right? And AD by DB is same as AE by EC, right? What is this is to prove? To prove that this is the basic aspect and concept that D is parallel to BC. If one line parallel to the one side of the triangle, then only this is true. Otherwise, it is not true for any non-parallel lines. Coming to that one. First, see the figure. In triangle ADE. In triangle ADE. Okay. We have to find the area of the triangle. What is the area of the triangle? It's a well-established formula that half into base into height. In triangle ADE, area of triangle is equal to half multiplied its base and the height. Okay, half. What is the base? No, I am going to take AD as a base. Okay, AD into what is the height? The height, if I take the base AD, then the height will be to opposite its vertex, a perpendicular line opposite to its vertex, that is what? En. Am I correct? En, isn't it? AD into En. Now you call this is an equation 1. Coming to the another part, area of the triangle. Now I have taken ADE, no, this ADE. Now coming to the, I told you AD produced to the DB, and DB is also going to form another triangle, what, that is DBE. So in triangle DBE, in triangle DBE, area of triangle, that is equal to half into base into height. Whose area? DBE. What is the base? How I have taken the side AD as a base, the DB is also be taken as a base. Half into DB into, what is it? Height. Its height is again En. Look here, viewers, please. Its height is En. And I am going to tell you that secret, that En is being taken common to both the triangle ADE and DBE. What may be the reason? Please give your comments onto my video. That why I have taken the En as a perpendicular or a height to triangle ADE, and En as a perpendicular or a height to the triangle DBE. But the height of the ADE falls inside, height of the DBE falls outside the figure. That you have to give the reason for that one. In my next video, inshallah, I will tell you what the reason. Okay. Now DB into En, it is a height. Now call this is an equation 2. Comparing equation 1 and 2, as these two triangles are no ADB and DBE, divide it. 1 divided by 2. Okay. What is 1? Half into AD into En, half into AD into En, divided by half into BD or DB into En. Then what is the common? Half of En cancelled, AD divided by DB. This is one part of the theorem, that is LHS, AD divided by DB. Now, you just remember that we have proved it by taking the left side of the triangle, that is the ADE and its produced side. Okay. Now, the same way we are going to take the another side. What the side it is? Listen. I have taken ADE and AD produced the triangle DB. Now again I take in triangle ADE. In triangle ADE. In my first part, I have taken the base as AD. Now I take, that is area of triangle is equal to half into base into height. Half into base into height. That is half. What is the base? This side I am taking. This base is AE. Okay. And the height is, if this will be the base, see that from this end, its vertex meeting perpendicular to this one, I take DM as a height. Understand? Half into AE into DM. Similarly, I have taken half into AD into EN now. Then you call it is equation 1. Area of triangle. What is that? ADE to its produced DB, I have taken DBE. ADE to its produced EC, I am going to take DCE. DCE. That is half into, what is its base? EC. And what is its height? And its height is DM. Again my question, I just would like to remind you and recall your memory that for one triangle the height is inside and for another triangle the height is outside. What may be the reason? Please give your comments below the just a comment box. Now see that you call it is an equation 2. Again dividing 1 divided by 2. 1 divided by 2, half of cancel, dm cancel, we get AE by EC. This is my right side of the triangle I have taken, it is AE by EC, and left side of the triangle it is AD by DB. Hence this is the proof of our theorem. What are some important points to remember? While proving the Thales theorem, AD is a common to both the part, that is for the BDE. What is BDE? It is a triangle formed by producing AD. It is a triangle formed by producing EC and joining CD and BE respectively. Okay. Then we have ADE, and this side base is AD, perpendicular is AN. This side base is AE, perpendicular is DM. This side base is DB, perpendicular is EN. This side base is EC, perpendicular DM. By this way, we have proved that what the theorem says. I hope you understand well, and remember there are some other things to just talk about the theorem in the last part of our this proof. What is that? It says that a D parallel to BC, then this parallel line divides the other two sides in equal proportion or proportionately. Number 2, the first part is what we prove, that AD divided by DB is equal to AE divided by EC, right? The second part is also that AD by AB is equal to AE by AC. The third part is that DB by AB is equal to EC by AC. Okay, these are the 3 parts. This is also Thales proportionality proof. This is also Thales proportionality statement. This is also Thales proportionality statement. Where D parallel to BC divides other two sides, AD divided by DB. AD is a part and DB is part of the AB. AE is a part and EC is a part of AC. Another way, a part of the AB AD and whole AB, a part of the AE AC and whole AC. This is the second part. We have to, it is also true for this proportion also. The next is, it is a below part of this AB DB divided by whole AB. It is the below part of the AC EC and divided by whole EC. This is also a part of the Thales statement. Okay friends and my viewers, with this I hope I am not going to take a very lengthy video so that you will be little bit bored and it should not be a monotonous. Okay, so once again I request you all, please do subscribe. What is the thing we are waiting for it? You have nothing to invest and you nothing to just incur your heavy amount in this one. Only you need to just make a little movement of your finger onto the bell icon or your just subscribe button, and you press it and you just spread it. There are many more. I would say that not only just how the sand particles are there, so many just tutors, teachers and well intellectuals are going to explain you this Thales theorem. Among them, I am also a tiny person just to tell you about my own ideas about the theorem. I hope you follow it. So don't forget to give your comment below this video that what is the main reason that the height of both the triangle is same. For one triangle, obviously it is very quite logical and understandable that it understood that its height comes inside. But for the other triangle, its height is considered as an outside. What is the reason? You have to just give your comment. With this, hope you will understand it, and very shortly we will come back with the Thales and some related theorems and the problems in my next video. Until then, take care and goodbye. Thank you.